Okay guys, we're going to start a new chapter here, chapter 3, and the first lesson in chapter 3 has to do with exponential and logistic functions. We're going to evaluate exponential expressions and identify and graph exponential and logistic functions. And then we're going to take note that exponential and logistic functions model many growth patterns, including the growth of human and animal populations. Exponential functions and their graphs. Alright, so we have the definition of exponential functions here. So an exponential function is any function written in this form. F of x equaling a times b to the x. A is going to be what we call the initial value, and b is what we call the base. Exponential are defined and continuous for all real numbers. It's important to recognize whether a function is exponential or not. So that's what we're going to do here in example 1. So we want to determine which ones are exponential functions, and for the exponential functions, state the initial value and the base. Alright, so we're looking for functions, again, in the form f of x equaling a times b raised to the x. Alright, so if we look at this first one, letter A, alright, this is going to be an exponential function. Alright, my A is going to equal 1, and my B is going to equal 4. So my initial value is 1, and my base is 4. In B here, alright, this is not an exponential function because notice how x is the base. So in order for it to be an exponential function, the variable x has to be the exponent. So this is not an exponential function. Alright, we look at C here. This is going to be an exponential, this is going to be an exponential function. My A is going to be -3. Alright, that's my initial value, and my B or my base is going to be 1.5. Alright, and then this last one is a little bit trickier. We have f of x equaling 7 times 6 raised to the negative x. So this is going to be an exponential function. Alright, my A is going to equal 7. Alright, now my B, alright, so I have 6 raised to the negative x. Alright, so I can rewrite this as 6 raised to the negative first power raised to the x. Alright, and so 6 to the negative first is going to be 1 over 6. So my base here is going to equal 1/6. Alright. Example 2 here. Now we have to compute exponential function values for rational number inputs. So basically what we're doing is plugging in 0. We're basically evaluating the function based on what x is. So in the first one, we want to find what f of 0 is for f of x equaling 2 raised to the x. So everywhere we see x, we plug in 0. So f of 0 is going to equal 2 raised to the 0 power, right? And anything raised to the 0 power is 1. Right, for b here, we have f of 4 equaling 2 raised to the 4th power. 2 raised to the 4th power equals 16. F of -3 is going to equal 2 raised to the negative 3rd power. Alright, we just did an example problem where we had a negative exponent, and how do we get rid of the negative exponent? We kind of flip and switch. So we take the reciprocal of 2, so it's going to be 1 over 2, and then switch the negative to positive 3 and write it underneath there. So 1 over 2 raised to the 3rd power, that's going to equal 1 over 8, or 1/8. Okay, D here, f of 1/2. That's going to equal 2 raised to the 1/2 power. Alright, and then we know that 2 raised to the 1/2 power is the same thing as the square root of 2. Alright, and so that's going to be my answer here for D. And then for E, we have f of -3/2 equaling, alright, so that's going to equal 2 raised to the -3/2 power. Okay, alright, and so what this is going to do is, well, what we want to do first is get a positive exponent, so we're going to flip the switch. Alright, so we're going to have 1/2 raised to the 3/2 power. Okay, and then from algebra 2, you should know that this is going to be 1/the square root of 2 cubed, and that is equal to 1/the square root of 8. And then you can plug that into the calculator. You don't want to leave we don't want the square root of 8, we don't want to leave that in the denominator, so if you just plug that into your calculator and evaluate 1/the square root of 8, you get approximately something like 0.35 4. Okay, you get something like that. Alright, and you can convert all of these if you wanted to. 1/8 would be 0.125, square root of 2 is something like 1.41. Alright. Okay, so those first two examples hopefully weren't too difficult. In example 3 here, we want to find an exponential function from its table of values. Alright, so determine formulas for exponential functions g and h whose values are given. Alright, so we have g of x here, and we have h of x here, and we want to write exponential functions for each. Okay, so exponential functions for g of x. So we want g of x in this form, g of x equaling a times b raised to the x. Well, we know that a, okay, is my initial value. Alright, so that's where I'm starting with when x is 0. So when x is 0, my y is going to be 4. So 4 is going to be my initial value. So g of x, I'm going to need some more room. So I'm going to say g of x equals 4 times b raised to the x. Okay, now I need to find what b is. And so what I'm looking for is either my growth factor or my decay factor. Alright, and this is going to be constant for these exponential functions. So what I'm going to do essentially is set up just a mini equation and solve for x to find what my growth factor is. So what I'm going to say is, so to go from 4/9 to 4/3, what do I have to multiply by? So 4/9 times, oops, let's do this, 4/9 times what number is going to give me 4/3. Alright, and so what I'm going to do is multiply by 9/4 both sides. And I'm going to get x equaling 3. Okay, now this factor is going to be constant for all of for this whole exponential function here. So my b is going to be 3. So I'm going to rewrite. I'm going to erase all this. I'm going to rewrite. I'm going to say g of x is going to equal 4 times 3 raised to the x. Okay, now it's very important, don't want to make this mistake, it's very important not to simplify this and say g of x equals 12 to the x. So please note that g of x here equaling 4 times 3 to the x, right, that does not equal 12 to the x, okay, because 3, we're raising just 3 to the power of x. We're not doing anything with this 4 here. Alright, okay, so I'm going to erase this, and now we want to find what h of x is. Alright, so h of x is going to equal, again, a times b to the x. A is my initial value, so that's what my my y value is when x is 0. So it's going to be 8. So h of x is going to equal 8 times b to the x. Alright, and so what do I have to do now to find for b? Well, you just got to set up an equation to find what either my growth or my decay factor is. So 128, alright, 128 times what is going to give me 32? Well, divide both sides by 128, and I'm going to get x equaling 32 over 128, and I'm going to get that equaling 1/4. Alright, and so that's what my b is. So h of x is going to equal 8 times 1/4 8 times 1/4 to the x. Alright, so what I did in this example was found the formulas based on I found the formulas for an exponential function based on a table of values. Alright, so that's my final answer there.